All right. How do I? There we go. Got to go back in there. Hello, hello, hello. How is everybody doing out there? So, the special people out there that are watching this knew that I was going to do this. The rest of you didn't. And if you're not one of the special people, well, I encourage you to go to the channel Bad Science Sunday and subscribe. And then I almost said describe. And you might then become a special people. I was originally, so this is Stephen Meyer. This is a Stephen Meyer video. I don't know if you guys can see that, and my thing might be in the way. This is a Stephen Meyer video. He had one that he posted almost 2 weeks ago that was on origins of life stuff that he was talking with Ben Shapiro, and that was originally what I was going to cover on this Imprompt Tuesday. But when I went to his channel to pull that video up, I saw this. And let's just say we're going to talk about this. We're going to talk about this instead. This I think this is only 1 day ago. Did the Big Bang prove the universe had a creator? Did it? I don't know. I hope not. Wait, hold on. What is that? Is that just me? Is that just me? Is that just in my StreamYard? Okay, yes, it is. Half of my screen share like disappeared in my StreamYard, and I at least hope that was just in the StreamYard and not for the rest of you to see. Did the Big Bang prove the universe had a creator? We've got Justin Brierley here with Stephen Meyer. Stephen Meyer's obviously going to do most of the talking. Let's just jump right in and see what he has to say.
Let's start with the Big Bang cosmology. Perhaps you could just sketch sort of where we were and where you feel we are now when it comes to the implications of Big Bang cosmology on our ideas about agency behind the universe.
Yeah, right. Absolutely. And if you don't mind, I think there's a nice framing quotation for this discussion, and it comes from Richard Dawkins himself. He says that the universe has exactly the properties we should expect if at bottom there's no purpose, no design, nothing but blind, pitiless indifference. Where
I have never in my life heard a quote as commonly cited and abused as that quote by Richard Dawkins. Not that anybody gives a fuck what Richard Dawkins of all people has to say, or at least you shouldn't. But like I just don't like. Okay, he said that. That's a thing that he said that one time a long time ago. I don't care. It doesn't mean anything. Certainly doesn't mean anything to cosmology.
Blind, pitiless indifference is his shorthand or poetic way of expressing the idea of strictly materialistic processes. And I love the way he frames the issue, because he's implying that metaphysical hypotheses, in his case, scientific materialism, in my case, theism, generate expectations about what we ought to see in the world around us. That
perhaps they do. I think it's worthwhile that you will frequently hear this materialism or scientific materialism or atheistic materialism. These are not terms that you actually see in the philosophical literature on physicalism or naturalism. The terms you're going to see are just as I have used: physicalism or naturalism. Generally, more broadly, you're going to see naturalism. That's metaphysical naturalism. That's generally the way that you're going to see this idea talked about in the literature, that it's the natural world, the physical reality that we inhabit, that's all that exists, that's all that's there, that's all that's real. These other terms are just not used. Like, if this was like 1934, maybe we'd still be using those terms, but it's not, and we don't. Also, I think it's worthwhile to point out, I think that's a really important thing to point out. This is not the way that like modern metaphysicians or like philosophers of science talk about this stuff. It's just not. They don't use these terms. But also, naturalism or physicalism or materialism doesn't have anything to do with atheism. You can be an atheist and be absolutely none of those things. I don't know where people think that like atheism entails you have to be a materialist or a physicalist or a naturalist. It doesn't. It never has. You just think that gods aren't real. That's it. That's where it starts. That's where it stops.
That metaphysical hypotheses, every bit as much as scientific ones, are testable against observations of the actual physical.
I think certain metaphysical hypotheses might be empirically testable. I don't think all of them are, though. I don't know if I would say theism is empirically testable. That being said, I do think that metaphysical hypotheses can be predictive. There can be expectations about the way that the world should be, or the way that we should see the world, if they're true.
And biological worlds. And so the question I raise in Return of the God hypothesis is, well, is that true, though? Is it true that what we observe is what we'd expect on a materialistic...
I probably should have said this before we even started the video, but I know I'm pausing a lot, but that's just what these are for, right? You're not here to listen to Stephen. You're here to listen to me. Everybody here to listen to me. That's why you come to this channel. Anyway, this is not probably going to be a very long stream, an hour at most. This, as you can see, hold on, is a 15-minute video. Maybe you can't see that. I don't know. It's a 15-minute video, almost 16 minutes. So it's not going to be super, super long. But I originally, like I said, wanted to talk about that Origins of Life video, which was about the same length and time that this is. And then I saw this. And so now we're going to talk about this. But it won't be a super long stream.
Understanding of the origin of the universe and the origin of life, and etc. And cosmology is the first place where I think it's pretty obvious that what the materialists expected to find is not what they actually ended up observing. And this has created cognitive dissonance through across now virtually.
I don't think naturalists really have any particular or very specified expectations about what we should expect to see with regards to the origins of the universe, or whether that's even meaningful to talk about. So I skimmed through this video before starting this. I didn't watch the whole thing all the way through, but I kind of jumped around. I usually do that, jump around a little bit, get a general idea what the video's about, just so that I can put myself in the right mindset and kind of have an understanding of the material before going in and responding to it. But I don't think he answered the question that was initially asked about sort of what the state of cosmology is and how this relates to this idea of there being some sort of what's the word I'm looking for? Why am I drawing a blank? Some sort of agent that sits behind its creation or something like that. I would like to touch on that just because I think it's important. I think there are some nuances that most people don't know about that I think are important nuances to make when we talk about early universe cosmology, cosmogony as it's often called. The Big Bang, or the hot Big Bang phase of the universe's evolution, is not the absolute earliest that we have some understanding of. There's inflation, which a lot of cosmologists tell you we haven't directly observed inflation, but it would be really hard to get a universe that looks like ours without something like inflation happening. Obviously, there's a small subset of cosmologists, albeit small, they are doing serious work, who do not agree with an inflationary picture. I am a non-expert. I tend to align with the consensus of relevant subject matter experts. I lean toward inflation with a high degree of confidence. I think that's what most cosmologists would say. That's what I've heard most cosmologists I've spoken to or have listened to say, is that they lean towards inflation or something like that with a high degree of confidence. So taking that inflation was something that happened, that this exponential expansion in the universe, very, very early in the universe's evolutionary history happened. The hot Big Bang phase is what would technically be called the reheating phase that immediately precedes the inflationary epoch. So you would have this inflation, this exponential expansion of space. Then that comes to an end, and what immediately follows is the Big Bang. Inflation being an exponentially very, very, very rapid, a sort of a super rapid expansion, would have obviously cooled the universe. I mean, this is how a refrigerator works. It cools gases or it expands gases, and that cools air. So this would have been a super cooling event at the same time that it was a super expansion event. And when it stops, the universe would heat back up, reheating. And it is that moment, that sort of phase in the universe's evolution that is referred to by cosmologists as the hot Big Bang phase of the universe's evolution. So there is a before the Big Bang, almost certainly inflation. Now, one might say, well, why did inflation happen or what caused inflation? We don't know. I don't know. Alan Guth, the father of inflationary theory, does not know. We don't know. We do not have physics that is capable of being meaningfully applied to these energy scales and these time scales and what have you, such that we can get meaningful descriptions of what is going on and give meaningful accounts of the entirety of the history of the universe. Could there be some sort of absolute beginning, as it's often said? Sure. At the end of the day, I can grant that. Obviously, Stephen isn't really running a cosmological argument here, but I can grant us this notion of an absolute beginning. I don't think it really does anything. But at the end of the day, you would be very hard pressed to find a professional cosmologist or just anybody doing early universe physics, which they're probably going to be a cosmologist. That's cosmology, a part of it, that thinks that the universe was created by an agent or designed by an agent. Even there are some that are Christian that don't even think that. I don't know how many. I don't know if it's most. I don't know any of those details, but I do know that they are out there. So that's sort of the state of what the Big Bang is, where cosmology is, and the state of this idea that there's some sort of agent that caused the Big Bang or that created the universe. We have no reason to suppose that. A lot of that goes into how we infer things like design or creation in the first place. I'm not really going to go down that road because I don't think it's relevant, and I've been rambling for long enough. So,
virtually a century, because the first indications that the materialist expectation was inconsistent with observations came in the 1920s, maybe even back to the teens.
So they weren't materialist expectations. They were just the general expectations of cosmologists at the time who thought that the universe was eternal and static. And they were wrong. Even the Christian ones thought that. And they were also wrong.
The standard understanding of the origin of the universe was that there had not been an origin event, that the universe was eternal and self-existing. It did not need an external creator. It had always been here, and therefore there was nothing external to it that needed to act to bring it into existence. It was what worldview scholars and philosophers sometimes call the prime reality. It was it was the thing from which everything else came, matter and energy in space and time. And the big discovery of at least by the 1920s, we were getting very strong inklings from observational astronomy that the universe was expanding outward in a roughly spherically symmetric way. This came from the redshift data that Hubble was collecting at the Palomar Observatory through his big 100-inch telescope. Previously, Vesto Slipher had been getting similar data about nebula before he knew that the nebula were actually galaxies. And so we had this observational evidence of an expanding universe. And just very simply, if you wind the clock backwards on that, in the forward direction of time, the universe is expanding. But you wind the clock backwards in your mind's eye, and you realize that the galactic material would have been closer and closer and closer and closer together at every point in the progressive past, till eventually you reach a limiting case where everything would have congealed to a starting point, and arguably the beginning of the universe.
Everything would have congealed. I'll use that word. That's a cool word. To a point where, like, it's extremely hot and extremely dense, and then our physics just kind of stops. And this is the thing that I was sort of touching on earlier that is missed, is that it's not that we reach a point and that we can't. It's just like, do not pass go, do not collect $200, at least as far as we know. It's that we reach a point where all of our ability to describe and understand physical reality, all of the models that we've developed, all of the theories that we apply, they all just stop working. Like, we reach a point where they kind of just say, hey, what? No, you're abusing me. I stop that. That doesn't bend that way. Like, they stop working. That this does not necessarily imply that this is a beginning point or a creation point. What it implies is that our physics stops working. And we don't know. We can't say anything about a before this, if there even was a before this, or what sense we can make of it if there was. What was going on, what was happening. The cosmologists don't know, the priests don't know, the pastors don't know, and especially the apologists don't know. So it's not like we've reached a point where it's like, oh, the universe just stops here. This is the edge. No, it's, hey, our models are no longer returning meaningful results. We've reached the limit of the applicability of the models of physics that we currently have as they sit within where we are in human society. We need to develop better models, and we haven't gotten there yet. It's being worked on every single day, but we haven't gotten there yet. That's really the takeaway from this. Physicists didn't hit sort of a wall and go, oh, this must be the edge. It's more like the car ran out of gas. This doesn't mean it's the end of the road. It means this is as far as our technology, as our capabilities are capable of taking us currently.
Universe itself. And you had a parallel development in theoretical physics with Einstein's development of general relativity. 1915, he realizes that from his own equations of his own field equations, that the universe must be dynamic and expanding.
Well, Einstein didn't realize that. That was something more that, of course, I'm drawing a blank. Georges Lemaitre was the one who really did that. Einstein believed the universe was static, and once Georges Lemaitre showed that the Friedman solutions show that, well, either the universe is expanding or contracting, and then Lemaitre was like, well, when we consider the observations that people like Vesto Slipher, people like Edwin Hubble were making, that, well, it seems that the universe is expanding. And then Lemaitre was like, well, if that's the case, the past history of the universe would be one where, as Stephen Meyer correctly pointed out, the further back into the past we sort of look or are capable of extrapolating, the denser the universe would have been, the more energetic, the hotter it would have been, until you reach a point that Lemaitre himself referred to as the primeval atom. So this is sort of the development. Einstein added in the fudge factor, the cosmological constant, because he didn't think this was the right picture of the universe. He thought the universe was static. So it wasn't Einstein. His equations, when applied to a universe that looks like ours through the Friedman solutions, give a universe that isn't static. And then modern observations tell us that out of either expanding or contracting, it's expanding. But Einstein didn't like that idea, adjusted his equations to account for it, and later referred to it as the biggest blunder of his career, I believe, if I'm getting the history correct there.
If gravity, as he's conceived it, is the only force operating in the universe, then all the material of the universe would congeal upon itself, and there would be no empty space. We would be in one big black hole. But we don't live in that kind of universe, he realized. And there's empty space between bodies, so there must be a counteracting anti-gravity force that creates that empty space, which suggests a dynamic universe that's, again, expanding. And so Einstein famously jerry-rigged his own equations and attempted to portray the universe as static, in a way, so that what he did is he introduced an exquisite degree of fine-tuning so that he could depict the gravitational pull inward as exactly counterbalancing the anti-gravity force, now known as the cosmological constant, pushing outward. But later it was shown that didn't actually work from the physics standpoint of things, that even slight perturbations would cause either a recollapse or an expansion. And then there was the data from the red shift, which showed that the universe actually was expanding. And Einstein,
and I think it is worthwhile, because obviously credit where credit's due, and this is why I think Stephen Meyer is like slightly above a lot of the other apologists out there. Like, I don't think he's stupid. I think he's wrong, but I don't think he's stupid. He is technically correct there. The one solution, I think, to Einstein's field equations that I think can sort of describe a universe like ours, but is static, is very, very unstable, such that extraordinary minimal perturbations, I think in like the initial conditions or what have you, would lead to a universe that either expands or collapses. And so it's not a very likely scenario physically to play out. Obviously, we know the Friedman solutions capture it. This is what the current standard model of cosmology is based on. For those who have read or seen or heard stuff Related to that, they've probably heard of the FLRW metric or the Friedmann-Metro-Robertson-Walker metric, which is the result of the development of obviously 4 guys who contributed a lot to this kind of model and to the mathematics that we use for describing the universe as we see it today.
Famously,
its
in
evolution over
1931,
its history.
acknowledged this. He went out to the Hubble telescope and had a look for himself with Hubble, famous newsreel footage, and then 2 weeks later gives an interview with the New York Times and acknowledges that he was wrong, that Hubble and his colleague Humison had shown that the universe was expanding. It was not static. There must be a beginning. And then we had, a century of debate about whether that initial conclusion held or not. But there was the steady state universe. There was the oscillating universe. There have been attempts to get around the beginning with quantum cosmology. But eventually, I think the consensus now that the universe had a beginning, and that even space and time are part of what came into existence, I think is completely unexpected from a materialistic standpoint. The universe.
So again, it is not the consensus of modern cosmologists that the universe had a beginning. I think, again, most cosmologists would be like, I don't know. Given the models that we have been able to carry forward the most, probably not. Not in any way that we would understand a beginning. But right now, we don't know. We really only have toy models at this point. But I can say with a high degree of confidence that modern cosmologists would say that the Big Bang, or if there is a beginning, and even an absolute beginning, this isn't a moment where space-time come into existence. I'm debating whether I want to go down this road or not, because it's something I've talked about a lot on this channel and other places I've appeared, where there's a difference between beginning and begins to exist. And an example that most people that have heard me talk about this are going to be familiar with it, that I use frequently, is that imagine a house. Most of us understand what it means to say that the house begins at the front door. Obviously, people can debate details of that, but just generally speaking, most people would be like, yeah, I understand what's being said when you say that a house begins at the front door. I don't think most people would agree, however, if I said that the house begins to exist at the front door. And this, I think, is the best way I have found, or examples similar to this. One that William Lane Craig has used is, you can imagine sort of a ruler that starts at the first inch and then, say, goes on potentially indefinitely in the other direction. Said ruler begins at the first inch, but the ruler doesn't begin to exist at the first inch. The ruler exists and it's bounded at the first inch. Likewise, the house exists and it's bounded by the front door. So if I granted that there was an absolute beginning to the universe, all that means is that there's a bound in one temporal direction to the universe, but the universe exists and it's bounded at one end temporally. But that's not like the place where its existence started. That's just not the correct way to look at the universe. And a lot of this comes down to the metaphysics of time, tensed versus tenseless views. Obviously, tenseless views have been empirically confirmed, so we don't need to concern ourselves with understanding time under some sort of tensed view, because we know that those are not the correct analysis on time.
The universe does not seem to have been eternal and self-existent. It had a beginning in the finite past. Therefore, that does raise the ultimate question of causality. What could cause matter, space, time, and energy to come into existence? And that question, I think, has re-raised the ancient considerations from the cosmological argument that the best explanation, the way I argue the case in the God hypothesis, is that the best explanation for the origin of the universe is something that must transcend matter, space, time, and energy. And therefore, you start to, the kind of entity that has those attributes or that meets those criteria is something like a personal God, an agent capable of initiating a change of state, and who has existence independent of the physical world, and that's God fits that bill. And therefore, the way I argue the case, that I think that either a deistic or a theistic God provides a better explanation for the origin of the universe than either a pantheistic or materialistic worldview.
A key question in all of this is whether the science, and you obviously cover this in great detail, does justify a beginning per se, because and I'm not a physicist or a scientist in this area, but my basic understanding of one of the objections might be, well, at the point where you go back to that singularity, you're not dealing with normal physics anymore, time anymore. You're dealing with something quite different. Something very different is happening in those first, tiny quantum seconds of the universe. And so to speak of it having been caused doesn't necessarily apply when you're talking about a kind of a quantum field or fluctuation in quantum vacuum or whatever you might say is that at that first moment. So is it legitimate to sort of say something must have caused this when you're talking about something very, very different to our normal experience at that point?
It's a very perceptive question, Justin, and something that I deal with in the last 3 chapters of Return of the God Hypothesis. And I think it's the most original material in the book. And that is that I show that in a sense, there's a decision tree. If you're a naturalist, if you are content to allow observational astronomy and general relativity to provide our best understanding of cosmology, including the earliest and part of the universe, you do definitely get to a beginning. You can.
Well, of course, I've already explained how that's not actually true, but I've also explained how granting some sort of absolute beginning to the universe doesn't actually get you any closer to God as a result of our analyses on time. And I think that maybe you could do an analysis on causation. I take causation to be strictly physical, so I would say it doesn't make sense to talk about causation solves the universe, because but then you're not talking about causation. Just like you can't say that a non-physical object has a color or a shape. Those are physical property. I don't know. I maybe you can, but then it's just on the person saying that to give a meaningful analysis of whatever it is they're trying to say. And I just have not been met with anything that I find motivating towards those positions yet. So much the same way I think most people would agree that it doesn't make sense to say that something non-physical could have a color or a shape or a size or mass. It doesn't make sense to say that it could have a cause or do any causing. In much the same sense, is that these are physical properties. These are physical notions that we ascribe to objects, entities, processes, what have you.
You can circumvent that conclusion or try to using what's called quantum cosmology and invoking the idea that as you back extrapolate, that you get to a point where the universe would be small enough that quantum effects would then come to predominate. We always have quantum effects with us, but they would predominate. And that's the idea behind quantum cosmology. And what I show in the book is that, well, if your cosmology is based on general relativity and observational astronomy, you get to a definite beginning, and that raises the question of ultimate causation. But then I show that quantum cosmology itself has its own theistic implications. And some of this, you have to get into some of the math of this, but basically what happens in quantum cosmology is that the earliest state of the universe is depicted as what's called a universal wave function. It's something that rather comes out of a universal wave function, which is not.
So this is a specific. This is a little bit more broad, I think, than specifically. Naturally, this can be applied within what's called quantum cosmology. But this idea of a universal wave function that can define as Stephen Meyer put it, that you could sort of get our universe out of. Of course, it could define the universe evolving along multiple different timelines. And in fact, all of those timelines are real. They're not separate universes. They're different timelines, world lines of the same one universe. And this is known as the many worlds interpretation, or the many worlds theory of quantum mechanics. This is more of a philosophical interpretation or framework for understanding quantum mechanics. It seeks to solve the measurement problem, explaining why it is that when we observe something, we never observe the superposition. We always observe it in a definite state. We can't sort of break that wall. Prior to sort of measurement, things exist in quantum mechanics. Things exist in a superposition of states, but when we observe things, they're always only ever in a definite state. Why can't we observe the superposition? That's what the measurement problem is really saying. Just for those that don't know, is why can't we measure superpositions when we make measurements? And so I this isn't like the way that quantum cosmology is done, but one can take an approach in quantum cosmology that utilizes this Everettian, I should say, many worlds interpretation. Hugh Everett's the one that developed it, so you might often hear it referred to as an Everettian model or the Everettian interpretation or what have you.
Not a physical state, but a state of but rather a description of mathematical possibilities. So you have this string.
Wait a second. Hold on. Let me.
Out of a universal wave function, which is not a physical state, but a state of but rather a description of.
Okay, so this is also not true within the many worlds interpretation. The universal wave. So the many worlds interpretation is, at least by my lights, and I've read Sean Carroll's book on this twice, is a what's called a wave function realist view. So in philosophy of physics, people know about wave functions, these functions of observables over space and time for quantum states. Are wave functions, which are mathematical, are they like real things out there in the world? Or are they just merely some sort of math, using mathematics to capture something about the actual world? Now, myself, I'm what you would call a wave function anti-realist. I don't think wave functions are like physically real or real things out there in the world. But within the many worlds interpretation, at least as I understand it, they are wave function realists. They think the wave function really is a thing that really exists actually, and it's like a thing. At least a universal wave function wouldn't really be a thing out there in the world, because the world would result from the universal wave function, but that the universal wave function is a real thing and it exists. So it's not just this purely abstract or conceptual mathematical thing. Whereas I think that is what wave functions are. I don't hold to many worlds interpretation, though I think it certainly has its merits. Most who do hold the MWI, the many worlds interpretation, are wave function realists. So I don't think it's quite accurate for Stephen to say here that this isn't something that's actually real. That the UWF, the universal wave function, is not something that's actually real. Within this interpretation, it's generally taken to be.
Description of mathematical possibilities. So you have this strange paradox in quantum cosmology where you get a physical universe out of pure mathematical possibility. And Hawking himself was very worried about.
So naturally, that would not follow.
About this, he said, what puts fire in the equations that give them a universe to describe? Even more poignantly, Alexander Velinsky, another advocate of quantum cosmology, in the end of.
There's the Stephen Hawking quote, "What breathes fire into the equations?" generally referring to like the fundamental constants and parameters of our reality. That's a whole separate discussion concerning the metaphysics of the laws of nature. Are the laws of nature even things out there in the world? If they are, do they merely describe reality, or do they like govern reality? Do they dictate to reality the way that it behaves? I'm not really going to get into any of that right now, just because, again, this is not going to be a super, super long stream, and I don't want to make it 2 hours or something like that. But there's a lot of discussion out there as to what like laws of nature really are, what their ontology is, what their metaphysics is, all of that. So I just think that's worth mentioning.
End of his little book, many universes in one, says before there was matter, space, time, and energy, what tablet were these quantum physical equations written on? Because he says mathematics in our experience is conceptual, and concepts exist in a mind.
Exactly. The math and physics that we use, and again, that as everything does, there's a lot of philosophy behind this. I am what you would call a mathematical anti-realist. I do not think that mathematical objects and structures are real things out there in the world that humans discover. I think that we can make discoveries within the mathematical systems that we have as given by the axioms that we choose. We can sort of invent a mathematical system, give it axioms, and then discover various consequences of those axioms within that system. But I don't think that mathematics is a real thing in the sense that it's a thing out there in the world. As Stephen Meyer has just stated, I think it's conceptual. I think it's a sort of a convented feature of the human mind. It's a convention of the human mind. It's something that humans came up with. So I don't think that there was a quote unquote tablet that the mathematical equations of the universe were quote unquote written on, quote unquote, prior to the universe. And there's a lot of this language that I'm not like really digging into because I don't want to do that. But I question the way that a lot of this is worded. I don't think it's very accurate, I guess you could say.
So if we're saying that the universe came out of math, essentially, are we?
I don't know any physicists that would say that. There's probably like one or two that you can find, but not most. I don't think most would say that the universe came out of math. I'm not really sure exactly how I'm supposed to interpret that. I think that could probably be understood a variety of different ways. I think it's a bit vague, but yeah, I don't think that's how it works.
Are we really saying that the universe came out of a mind? And so what I go into great detail on this in the chapters 17 and 18 in Return to the God hypothesis to show that in two separate ways, if you want to, there is a way to circumvent the conclusion of an absolute beginning, although even there, not entirely, because the singularity in quantum cosmology is never eliminated.
Not all quantum cosmological models have a singularity. In fact, a lot of them don't.
It's eliminated as an intermediate step in a mathematical transformation that Hawking performs, but he acknowledges that intermediate step exists in the realm. It's in the realm of imaginary numbers and has no physical correlate.
To get super technical on everybody here, just because I kind of want to, yeah, what Stephen Hawking does is, I believe he Wick rotates time about the complex plane such that time becomes imaginary rather than either real or complex. That's just sort of this Hartle-Hawking model where the universe sort of has this boundary, but it doesn't make sense, at least from a temporal standpoint, to call it some sort of beginning or something like that. There's just like a boundary, this temporal boundary to the universe. But calling it a beginning is just not the right language. It would be like calling the North Pole the beginning of the surface of the Earth. That's just not the right language to use to describe the North Pole. You might call the North Pole some sort of boundary or something like that, but to call it a beginning, that doesn't make sense.
Correlate. And so if you convert back to real numbers, the singularity reappears. So in Velinsky's quantum cosmology, there is still a singularity, an absolute beginning. It's also presupposed in the
Velinsky's model is just Velinsky's model. I mean, I don't even know if most cosmologists are working with models like that or similar to it. Those that are working in quantum cosmology, a lot of them, I mean, ADS-CFT correspondence is a big one. A lot of holography stuff. Holonomy, I think, is another term you'll see a lot. Obviously, string theory, conformal field theory. There's a little bit of like loop quantum gravity with Carlo Rovelli, but that's, I think, a lot of where that's where a lot of the people I think are at with respect to the models they're kind of working from. I'm not sure how popular Velinsky's model is, but again, it's Velinsky's model, and there are cosmologists who reject it.
In the Hawking-Hartle model, and is not really eliminated except as Hawking himself acknowledges as a mathematical trick. So the first thing to say is that you don't actually get rid of the beginning in quantum cosmology. But secondly, the attempt to get rid of it depicts the universe as arising out of a purely mathematical state, that a quantum field
quantum fields are not strictly mathematical. Quantum fields are physical entities.
A quantum foam is not a physical state. It's a
yes, it is. The vacuum state of a field is physical. That's why things like the Casimir effect are possible. And then also things like the Lamb shift in what is it? S and P 1/2 orbitals or something like that in the hydrogen atom. So our models predict it with the hydrogen atom that, like, hey, this is where the electron should be orbiting. And then we go out and we look at the electron orbiting in the hydrogen atom, and it's slightly off from where it should be, almost as if it's got just slightly more energy than it should. That's because it does. And that's because the electron is interacting with the, most people are going to, the quantum fluctuations, these transient fluctuations in the electromagnetic field, these quote unquote virtual photons are interacting with the electron, giving it slightly more energy and pushing it from where we predicted it to slightly sort of like higher energy than where we predicted it. And that shift in where, between where the electron was predicted and where it's observed, is called the Lamb shift. And this is a direct physical real result because quantum fields are physically real, and the fluctuations that are transient within them at their vacuum state, their lowest possible energy state, that's a real state of a real field that really exists, and it's physical. If it wasn't physical, I don't know how it's causing stuff to happen.
It's a description of mathematical possibilities. And even so, even beyond that, the mathematical possibilities have to be constrained in order to get a universe like ours.
By the way, just because I didn't say it, the Lamb shift has to do that. That was the last name of the guy who discovered that. It has nothing to do with like the animal. Just to clarify,
as the natural outcome. And so, and those mathematical possibilities are constrained by the choice of the physicist. And so you have possibilities like ours as the natural outcome, trained in order to get the mathematical possibilities have to be constrained in order to get a universe like ours as the natural outcome. And so, and those mathematical possibilities are constrained by the choice of the physicist. And so you have a big.
It's like that in all models, though. Like, I'm pretty sure that's what they're doing for all of our models. It's kind of how it works. We want to know what these models would look like, what sort of structure. I really hope that's not happening on the YouTubes, but it might be. The screen splitting thing. That's as I understand it, how like we want models that describe our universe. So we input the kinds of things that would give a universe like ours, and then see, okay, how do these models line up with observation? What sorts of conclusions can we reach about them? How accurate are these models? Do they help us move the field forward? That's, as I understood it, how physics is done. But like I said, I'm not an expert, so I could be wrong.
Big hairy equation in quantum cosmology called the Wheeler-DeWitt equation. It's the analog to the Schrodinger equation in ordinary quantum mechanics. It has an infinite number of solutions because it is a type of differential equation that has an.
Well, I mean, even in like quantum field theory, there's an infinite number of solutions that one can utilize. We just don't really care about all of that. Like in a lot of math, there's technically an infinite amount of solutions or an infinite amount of terms or something like that. And physicists have ways of dealing with those infinities. Those who have heard terms like perturbation theory sort of relates to it, but more like renormalization. These are just mathematical methods that physicists use to sort of control the infinities by cutting off stuff that's mathematically irrelevant to the solutions of the equations.
An infinite number of solutions. So the quantum cosmologist says they'll explain our universe if the solution to the equation gives a wave function that includes our universe as a reasonable possible outcome. But you can't get such a solution until the physicist constrains the degrees of mathematical possibility and essentially inputs information into the mathematical apparatus so that they can depict our universe as a natural consequence of all that.
Yeah, just to reiterate, they're constricting the probability space to a universe that resembles ours because that's the kind of universe we want the theory to be capable of describing.
So you've got the universe coming out of math, but also coming out of a math that has to be artificially constrained by an intelligence to get the right answer. It's a teleological end-direct.
Human intelligence, though. And that's because we already have a universe that looks like something. So it's that universe that we're going to want to constrict those models to describing. And even then, physicists will toy around and be like, okay, so what if we changed this? What if we did this? What kind of universe would you get? What would it look like? Oh, yada, yada, rama, rama, ding dong.
Directed simulation. So what you have is a mind inputting information to simulate the origin of the universe. That's what's happening in quantum cosmology. So I
don't think that's probably the best way to word it.
Actually, the move to go to quantum cosmology to get around the clear evidence at the beginning just ends up adding additional weight to the theistic argument.
Just one more question as we close out.
That was a little long and complicated.
No, it's fine. It's all good stuff. I mean, to what extent would you say there is a potentially a bias at play among some scientists who are committed to, say, methodological naturalism, to want to?
Well, methodological naturalism is more that's not the same thing as metaphysical naturalism. That's just saying that when we do empirical science, we're assuming that it is restricted to understanding the empirical world, that it's restricted to at least largely empirical methods. Maybe there's some certain analytic methods from mathematics that might be used, but we're sticking to what the empirical world is. That's what we're describing. That's what we're understanding. That's what we're measuring. That's what we're observing. That's what we're experimenting on or with.
Want to avoid, as it were, any possible divine foot in the door. I know, for instance, that when these models were first being proposed, Fred Hoyle was not a fan of them, arguably simply because he didn't like the implications.
He was explicit about
that. Yeah, but that was Fred Hoyle. That's not like everybody else who's not Fred Hoyle.
That. And
this is the thing that apologists will do. They'll say, well, this one guy said this one thing this one time. Sure. So guy had opinions. I mean, that doesn't mean that that's where the field as a whole is. It's not.
And that, he coined the term the Big Bang as a pejorative to make fun of it. He said he was a Democritean. He didn't believe that something could come from nothing. And he didn't like the idea of invoking a cause that he could never verify. Well, understandable. But science involves invoking all kinds of postulates that we cannot directly verify. Science has a structure where we infer from what we see to sometimes what we cannot see, and we hold as real those things that we cannot see because of their explanatory power with respect to the observables. And if that,
not even just their explanatory power with respect to the observables, but like that there are physical features manifest in the physical world that wouldn't exist if we've never, so to speak, looked at an electron. Like that's, we sort of infer their existence from the variety of interactions in which they play and the relations in which they stand. But the electrons are real. They're physical things. They're out there in the world. If they weren't, I don't know how the fuck electron microscopes work. I don't know how the lights are on in my house. Like it's not just the explanatory import, but you might say this causal import. They're causing physical effects that we can see, that we can measure directly. So they too must be physical.
And if that's legitimate to do that for subatomic particles or subsurface geological structures or molecular biological structures, or if you're a psychiatrist, states of mind in your patient, why is that a legitimate move to infer to an unobservable intelligent agent?
Because it doesn't have explanatory import, number one, and it doesn't really have any causal import, none that's been meaningfully demonstrated, at least. That would be why.
Responsible for the origin of the universe. The causal...
And then again, to reiterate a lot of what I've said in the video already, we don't know that the universe has an origin, so there's that fact as well.
Profile that's required to account for what we see directly matches what theism affirms about God. And so this is not an intellectually illegitimate move. This is the kind of thing that scientists and philosophers do all the time, in inferring an unobservable from the observables, where the observable entity inferred has the attributes that, if true, would be necessary to explain what we see. And you're right. back, sorry, I went philosophical on you, but just history, science, you had multiple attempts to circumvent the idea of a beginning. And in Hoyle's case, he was very explicit about his.
Yeah, but a lot of that wasn't because, oh God, oh no, it's God exists if we don't avert it. It was just that this isn't what cosmologists currently believe, and some people just don't like the idea of that model. They want to, get their 5 seconds of fame and showing that, oh well, what all the experts thought was wrong. Most of it has nothing to do with being scared of the theological implications, because there aren't really any theological implications.
His metaphysical motivations. He did not like it. He was a scientific materialist at the time. He then later changed his worldview, though, in response to his own discovery about the fine-tuning of the universe that was necessary to account for carbon in particular and life in general.
The universe is not finely tuned for anything.
General.
Alrighty. That ends that. Like I said, just a nice little shorty today. An interesting video. I gotta say, the more I listen to Stephen Meyer, like I really do. I mean, I think there's some stuff he says that's kind of dumb, but in terms of the apologetics that I'm seeing on the internet, I think he's like one step up on the staircase above other people. He's like 10 steps above somebody like Frank Turek or something like that. But I'm willing to listen to what he has to say more than I am probably a lot of other people that sort of orbit in that sphere. With that being said, I don't know what I've got coming up. I don't know if I have anything specific coming up. You'll see me out and about on YouTube. I might do something like this again. Well, it's ImprompTuesday, so you don't know when. Most of the time, I don't know when. But I shouted out Bad Science Sunday earlier in the stream, at the beginning of the stream. I will be on that channel on the 23rd, which would be not this coming Sunday, but the following Sunday, the Sunday before Thanksgiving week. I'm actually not sure what we're going to be talking about. It's probably going to be interesting, though. So I do have that coming up. I don't have anything planned thus far for the channel. I do actually want to get a debate up that I had probably 3 weeks ago. I'm fiddling around with this new editing software, so once I've got that figured out and feel confident enough to use it to do a little editing on the video, that'll probably go up. I don't know when that'll be, so keep an eye out for that. Other than that, I'm going to go ahead and end things, and I hope the rest of you have a wonderful evening.